Hi, good morning, everyone. I will talking about benzocaine functionalized silicon oxide with Europium luminescent nanoparticle for evolution in NAND-MB-231 cells. One of the main challenges in the healthcare fields is the low efficiency of conventional drugs delivered system. As a result, in recent years, there has been growing interest in developing new control relays carried among with silica-based materials, silicon oxide, stand up. These materials have been widely reported as biocompatible, not toxic, and chemical stable, in addition to having a high specific surface area that allows easy chemical functionalization and attribute that can be provide biological activity to the system. In this work, we develop a hybrid silica nanoparticle doped with 5 mol% Europium a lanthanide ion that exhibit a photoluminescent lifetime in the millisecond range, making it a promising luminescent proof for bioimaging application. And subsequently, the silicon oxide with Europium nanoparticles were functionalized with benzocaine, a topical local anesthetic, different concentration, and 20, 25, 50, 100, 150, and 200 milligrams. The nanoparticles were synthesized via a Stöber method using tetraethyl orthosilicate as a precursor. This process enabled the formation of sulfates, silice oxide, and SiO2 bonds, which are essential for sequenced benzocaine functionalization. Sample characterization was carried out using Fourier transform infrared spectroscopy with confirmed signal corresponding to characteristic functional groups. And X-ray diffraction analyze revelate pattern corresponding to both silicon oxide and benzocaine, confirming that incorporating of the drug into the matrix. Scanning electron microscopy images show an agglomerate morphology with flake-like structure. And the study of photoluminescence spectral displayed a characteristic emission at 612 nanometers attributed to Europium ion transition with higher luminescence intensity observed in sample functionalized with 50 and 100 milligrams of benzocaine. This suggests a favorable interaction within the drug and the dope system. Finally, MTT cell viability says indicate viability about 80% in all samples, supporting the potential of these nanoparticles as biocompatible for bioimaging application. That's it. Thanks for your attention.